Live from the BBC, The Naked Scientists.
Hello, welcome to this week's edition of The Naked Scientists, and it's our Naked Scientists Science Phone-In, an hour of Q&A, an hour of live, unplugged, unhugged science questions from you. You just call up, the number's 08459 25 2000. You can email, and we're using a slightly different email address this week because we have a computer problem. It's thenakedscientists@yahoo.com, thenakedscientists@yahoo.com, or of course you can text us, and our text number is 07786 20 1960. Any science question goes. My name's Chris Smith, and also here to tackle your science questions this evening we have Dave Ansell.
Good evening.
And we have Kat Arney.
Hello, and also coming up on the show, Chris is going to be telling us about the oldest bling in existence and how scientists may be finally getting to the root of Parkinson's disease. Dave will be telling us some trembling news about earthquakes, and also how we're going to be sending telescopes up to space on the cheap. And I'll be bringing some good news for pandas listening to the show, and also revealing how scientists at the University of Delft really are extracting the proverbial from our wastewater. So what else, Dave?
If you have any questions, give us a call on 08459 25 2000, and you'll have the chance to win 2 copies of the completed autobiography by Benjamin Franklin, compiled by his great-great-great-great-great-great-grandson Mark Skousen, who we'll be talking to later.
Thanks, Dave. And here's a quick question to kick us off this evening, and this one's from me. What was the first thing ever invented to break the sound barrier? Give us a call if you think you know the answer. 08459 25 2000.
The Naked Scientist Podcast, brought to you by thenakedscientist.com.
Now, I can't think of a person in the world who doesn't love pandas. We all love pandas, don't we?
It's the insignia of the World Wildlife Fund,
Exactly.
isn't it?
All the crew in the fishbowl, they all love pandas too. Pandas have been hailed by the environmentalist movement as something we should really be saving. They're cute, they're cuddly, and scientists have previously thought that we're down to about 1,000 pandas left in the wild. But thanks to some modern scientific methods, bit of the appliance of science, we think there now may be about as many as 3,000 pandas left. So pandas have become very endangered because they're hunted. The areas where they live in have become deforested, and they're not very good at reproducing, and they only eat bamboo, so they're not very efficient species. But previously, scientists have been working out how many pandas there are by basically checking the amount of droppings they leave and looking for signs of pandas. But now they've started to use DNA, fingerprinting techniques to actually genetically track these pandas and work out how many different genetic individuals there are. And the good news is, for pandas anyway, it looks like there's about 3 times as many as we thought there were. So maybe we can actually pull them back from the brink of extinction.
They say they're not out of the woods yet, though, or even out of the bamboo, don't they? Because the thing is that their habitat is still under threat because people are still impinging on it inexorably.
Exactly. I mean, China's a hugely growing economy, and if you only eat one thing, you're at great risk of becoming extinct if that thing keeps getting cut down.
Do you know offhand why people thought there were far fewer than this recent research shows that there actually are?
Well, they'd previously been tracking them by looking for droppings and signs of pandas, but it's quite difficult to tell the difference between one panda's droppings and another panda's droppings. And so now they're using these DNA techniques to actually genetically work out, whose droppings are whose and how many pandas there really are.
Because they're prolific producers of droppings, though, pandas, aren't they? 40 times a day they allegedly go.
That's news to me, Chris.
Well, their diet is so rich in fibre because they're just eating bamboo, which, let's be honest, the nutritional content of bamboo is not high. So the little bit of goodness that you can extract from it means that there's a hell of a lot of roughage, let's say, left over, and that all comes out again.
Well, there you go. I mean, they are not a very effective species.
But a lot of hot air produced, inevitably. But Dave, on the subject of hot air that rises...
Well, astronomers have always wanted to see as far as they can, and the atmosphere gets in the way. It's kind of a bit fuzzy, it makes the light go around corners, it blocks out some wavelengths, like ultraviolet, which is a good thing, because that way we don't get so badly sunburnt. But the problem is, the obvious way to get around this is to put a telescope up in space. Now, the way they've done that before with, like, the Hubble Space Telescope, the problem is this is really, really expensive. It costs, like, billions of dollars. Now, Robert Fenson in Dartmouth College has come up with a way around this. He reckons if you put a telescope on a really big airship, like the Hindenburg, you
wouldn't use the Hindenburg because it blew up, Dave.
Yeah, okay, not like the Hindenburg. A big blimp. Something much lighter. You want to get up really high. So you want to build a really, really lightweight airship. up to maybe 22 kilometres. So you can put up a telescope up nearly in space for about $10 million rather than 10 billion.
Can I just ask you something about the physics of that? Because when a balloon rises in the air and the air pressure drops, the amount of air pushing in on your balloon becomes less, and therefore the balloon gets bigger. So how big would the airship be by the time it got to 22 kilometres? Because that's pretty high, isn't it?
They're talking about sort of hundreds, maybe 500 metres long by a couple
That's huge, isn't it?
Huge.
Just for one camera. I mean, is this still efficient?
But compared to putting a satellite on a rocket, it's very cheap. It also means that if it breaks, you can bring it back down again and fix it, which is a major, major advantage.
The Naked Scientists, supported by the Wellcome Trust.
Now, a key disease which has really been something of an enigma in terms of its reasons why we get it, and was first described over 100 years ago, is Parkinson's disease. And it's been a neurologist's mecca to try and work out why this disease actually happens, and then to try and work out, is there anything we can do about it? Because ever since James Parkinson first described Parkinson's disease over 100 years ago, in the 1800s, he named it the shaking palsy to start with, scientists have got quite close to understanding why people get the symptoms of Parkinson's disease. They've got quite good at inventing drugs that can help people overcome some of the symptoms of Parkinson's disease. But really, the number of therapies out there that can slow the disease down or even stop it, so that once you're diagnosed with it, you know you're not going to get any worse, well, that's been a real challenge. But now there's a group of scientists led by a guy called Anthony Cooper over at the University of Missouri in the States, and they've published a paper in a top science journal, the journal Science, this week, and they've actually found why it is that certain cells in the brain that are linked to Parkinson's disease do begin to die, and therefore that casts doubt on whether or not we will be able to stop the disease or not. And it looks encouraging that now they've highlighted a target in these cells that means we might be able to home in on that target and arrest the disease process. What have they found? Well, they've found that the cells essentially become deluged in cellular rubbish or garbage that builds up because there's a certain, if you like, conveyor belt in the cell that ferries material around and takes material which is rubbish and takes it to the incinerator to be degraded and burned up by the cell. And in these cells, this stuff accumulates to such a high level that it inactivates that conveyor belt. And what they've been able to show is that if you can increase the amount of this substance that makes the conveyor belt happen, then you can make the cells get healthy again. And this suggests you should be able to stop Parkinson's disease in its tracks. And that's a gene called YPT1 or RAB1. And so what they're looking for now they've got this target to aim at, is a drug that you could turn on that gene with. So if you gave that drug to people, then they could increase the level of that in their cells, and potentially it would overcome some of the disease process and stop Parkinson's disease in its tracks. So congratulations to them, and I wish them all the best with that.
Yeah, let's hope they get on the case quickly. I mean, it's one thing to discover a gene and work out what it does, but then to find the drug that actually works and get that through in testing. Hopefully maybe 5 years, do you reckon, Chris? We're getting better at drug development.
The thing is that the time it takes between a test tube and an actual patient, a needle going into a patient, is in the order of 5 to 15 years, and a price tag of anything up to £500 million. Most drugs, the cheapest drugs, cost about $500 million to get to market, because the amount of testing that's required to make sure they're safe is huge, and it involves thousands of patients, and so it's a big price tag.
Certainly in the field I work in cancer, it's a really big issue how long it takes and the money. But anyway, moving away from that and moving to a slightly more scatological theme. So when you go to the toilet, am I allowed to talk about this on the radio? I've got to be careful. When you go to the toilet, when you wee, it goes into the sewage system. And there's sort of a problem with wee, because we eat food and we metabolise it and we break down proteins to make things like nitrogen and phosphates. It's actually very rich organic matter in our wee, and it's very difficult to process. And the sewage system takes a lot of energy to get this out of it. So scientists at the University of Delft are proposing a radical solution that we actually collect our wee separately and process it separately. And if you can do that for about 50% of urine, you can save a quarter of the energy demands required to purify sewage waste. So they propose you would collect all the urine from, say, a town. You could have a local wee processing plant, and it would significantly reduce the costs of processing sewage. And then also it would mean that your sewage smelt less. There would be less pressure on the environment around it, and also your sewer pipes wouldn't rot so much. So maybe
but how do you get the stuff to this collection point? Because if your point is to save energy, it's a bit like recycling. Sounds like a great idea. Let's recycle everything. But then if you end up having to have a big lorry which is burning up loads of fuel and it's bad for the environment, it's got to go around everyone's house and pick up this paper, which then actually ends up rotting in a warehouse because no one wants to recycle it. That's worse for the environment. So how is this better for the environment, energetically speaking?
Well, they have looked into that. So they're proposing initially that you would collect it through a separate urinal, which would be an energy cost. But ideally, you'd have decentralised, so very local reprocessing of your sewage.
Because interestingly, urine used to be collected several hundred years ago to make gunpowder. Because if you mix urine with ash, you get saltpeter, which you need to blow up. To
potassium nitrate.
Potassium nitrate, which is the actual oxides which make things explode. So it's almost going back to an old idea.
But
Wow.
Even before that, if you go back into the sort of 17th century, when phosphorus was discovered, scientists were interested in urine because it was a golden colour, and they thought that perhaps it was golden because it had gold in it. So why don't we boil up loads of urine? So there were a couple of scientists in Europe, and they got gallons and gallons of urine from wherever they could and boiled this stuff up and under very harsh conditions, very high temperatures. And they got this amazing stuff that when you exposed it to air, gave off light. It glowed, and the reason it glowed is because it was phosphorus. It was pure phosphorus, and it was igniting on contact with the air. And when one of those scientists came to the UK, he went to the Royal Society in London, and I think it was Robert Boyle who was there at the time, who was running the Royal Society, and he put this stuff on the floor to show Robert Boyle what it could do in this assembly of the Royal Society. And they put all the lights out, and this stuff lit up because he'd written on the carpet on the floor with this stuff. And Robert Boyle's sister went mad because she was frightened it was going to make holes in the carpet. But science was made in London in the early days then.
Well, they're also saying you could extract the phosphate from this, so, a return to that maybe.
Well, look, talking of burning things, I've got a quick email here from Charles, and he's listening in Seattle, Washington, in fact, and he says, hello, your podcast is by far my favourite. It's awesome. That's the Naked Scientist podcast, by the way, which you can get through iTunes and other podcast aggregators if you want to. nakedscientist.com/podcast. He says, my question is, why is it when I eat spicy foods, my tongue burns and I perfuse, I think he means perspire, like crazy? Also, why is it that when I then drink water, my tongue burns more rather than less? Thanks a lot.
It's something to do, I think, with the chilies stimulate your sort of nervous system, don't they?
Yeah, I think I know the answer to this one, because
to the body.
chili has got a molecule in it called capsaicin.
Yeah.
And capsaicin locks onto a certain channel on the surface of nerve fibres in the mouth and all over the body, in fact, that signal pain. And so when the capsaicin molecule from the chili locks onto that nerve fibre, it activates the nerve. And so the same nerve fibres also signal temperature. So it fools the nerve into thinking that you're hotter than you are. So you get that heat reaction. And that's why you often get a red face and you get sweating to go with it, because you've got this going on in your mouth. The reason that water doesn't make it better is because it dissolves in oil. It doesn't mix with water. It's an oily molecule. So putting the water in doesn't make any difference because it's locked onto the nerve cell.
And there's a great tradition in Indian food of serving it with things like yoghurt, very yoghurty drinks, because that sort of helps to diffuse the
Yeah,
chili.
and there's also fat in the yoghurt, and that's going to be my next point. If you want to get rid of it, you need something with some fat in it. And in fact, alcohol will also dissolve capsaicin. So a slug of beer should help it to feel better.
For all those people going out to celebrate the World Cup.
Okay, there's some slightly worrying news for people living in California. Yuri Falco from the University of California has been doing some very accurate satellite measurements of how the plates, the Earth is split up into these huge plates and they're slowly moving past one another. And he's been doing very accurate measurements of the plates to the southwest of LA. And apparently the rock a long way away from the plates has moved 8 metres, but right next to the joint between the two plates, it hasn't moved at all. So there's about 8 metres of tension in the rock waiting to be released.
Is that big?
It's enough to produce a magnitude 8 on the Richter scale earthquake if it all goes at once.
Crikey, what's going to go?
Looking at my map, it's not too close to Los Angeles, but I guess it could cause some really serious problems.
Well, if you think the great earthquake in San Francisco in 1906 is 100 years since that went off this year, so it's pretty timely that we're now looking at this again. That only ruptured a 300-mile segment of the northern reaches of the San Andreas Fault. And this piece of research looks at the southern reaches. That 1906 earthquake was felt as far away as Oregon. And it did, in the order, I think the estimates are $500 million worth of damage at the time. So you can imagine what would happen today.
messy.
It's going to be messy.
Our question we're asking you at home this evening is, what was the first thing ever made to break the sound barrier? Joshua in Williams speculated the first thing was Concorde and then changed his mind and suggested it might be the V2 rocket. That's not quite right, Joshua. Keep trying. We've had an answer from Alan in Bar Hill, who is on the right lines, definitely on the right lines there, Alan. Well done. If you think you know the answer, give us a call. It's 08459 25 2000 on the telephone. You can send us a text message if you want. It's 07786 20 1960, or you can email thenakedscientists@yahoo.com. Kat.
Yeah, we've got an email in here relating to a liquid nitrogen experiment we did on Kitchen Science a few weeks ago, freezing things down and smashing them up. And he wants to know, it's from Derek, and he wants to know, why do living tissues turn black after being exposed to critically low temperatures? So, for example, if you get severe frostbite, you get this kind of black, dry gangrene. But he says, well, it's not to do with bacterial infection, so why does it all go black? Now, I think it's to do with the same process that turns your skin black or this very dark green if you get a severe bruise. And that's caused by hemoglobin and iron products and things like that in your blood oxidizing. Because basically, if an area of skin is very damaged, for example, with frostbite, there's Dave looking at his hands suspiciously.
No comment.
Then obviously it's just become dead tissue, so all the blood that's left in there is going to start to break down in response to the air.
I guess, is this related to the way that blood goes very dark black when it's been exposed to the air in a scab or something?
Exactly, sort of. It's basically all dead tissue oxidising and breaking down because it's a lifeless area.
Yeah, so you damage the area, the blood vessels supplying the area switch off, and the tissue is so-called devitalised. And also, the point we should add here is that when something gets frostbite, when it freezes to that extreme, you get ice crystals inside the cells, which are very jagged and spiky, and they pop all of the cells in the tissue. So it's not just the surface that gets damaged, it's every bit of tissue inside the frozen area that gets... Essentially, it's like you hitting your hand with a mallet internally. And so as a result, it's just a jellified mess inside, and all the enzymes that are locked away inside cells escape onto the outside, and some of those are quite nasty. They're like stomach enzymes that can break things down, but obviously they're locked away in safe parts of the cell normally, and they get out and start degrading tissue, and that all chews the tissue to pieces, and you get this nasty black mess, which is, as you say, the oxidation products and a lot of iron in the blood that goes black because it's your hands going rusty.
Nice. Anyway.
Sorry, Scott, I was going to say, quick call from Fred, who's in Colchester. This one, maybe you can comment on this. When we go to the GP, he often gets his blood pressure tested. How often do the instruments that are used to do these kind of things get checked out to make sure they're actually accurate?
I hope that they do. I don't know.
Well, important, because if you were to say... if you were to make an error of, say, 5 millimetres of mercury, because normal blood pressure is, say, 120 over 80, and so 5 millimetres of mercury would be a very, very small error, then you could be diagnosed as having high blood pressure and end up being on treatment. So the answer to reassure you, actually, Fred, is that they're checked regularly and they are calibrated, so everyone knows that they're absolutely right.
That's a relief. Anyway, we're going to head stateside now and catch up with Bob Hirschon and Chelsea Wald, who are going to bring us this week's science update. And they're looking at feeding tactics and killer whales and learning about equine communication, you guessed it, straight from the horse's mouth.
For the Naked Scientists this week, a Dr. Dolittle for horses trying to understand the meaning of the whinny. But first, killer whales aren't really whales. They're actually a member of the dolphin family. And they aren't really killers either. Well, at least not of humans. Chelsea tells us about how some of these misunderstood creatures really get their meals.
These Icelandic killer whales aren't making these sounds for fun. They're using them to hunt their favorite food, herring. That's according to Lee Miller and his colleagues at the University of Southern Denmark, who recorded the sounds. As the killer whales close in on their prey, they smack their tails underwater. The thud stuns the fish. What's more, Miller's team discovered that Icelandic killer whales produce a steady tone just before the tail slap.
So you always hear like a sound, doo, boom. And the sound always ends just before the tail slap. And we think that maybe this sound will cause the fish to get into a tighter ball,
making it easier for the killer whales to get a meal.
Thanks, Chelsea. After a well-known American racehorse named Barbaro was injured earlier this year, reporters asked his vet how bad the injury was.
And he says, it's very difficult to tell because we can't speak to them and they can't speak to us.
That's physicist David Browning of the University of Rhode Island. He and a colleague are trying to overcome this language barrier between humans and horses by studying whinnies. His preliminary study shows they're quite varied.
We don't really have enough samples yet to really get a handle on the trends, but the frequency can increase quite rapidly at the start and then taper off slowly. Or you can get this characteristic tremolo, what you get on a whinny.
He hopes to determine what, if anything, the horses are communicating with this rich repertoire.
Thanks, Bob. Next week, we'll talk about an ancient rock carving that might actually be an astronomical record. Until then, I'm Chelsea Wald.
And I'm Bob Hirschon for AAAS, the Science Society. Over to you, Naked Scientists.
Thanks, Bob. And if you want to hear more from Bob and Chelsea, you can go and check out their website, www.scienceupdate.com.
I've got an email here from Daniel Bahar, and he's actually in Israel. And he says, been listening to your podcasts here in Israel for several months, and I find it informative and entertaining. He's got a question. He says, my daughters Mimi and Yale would like to ask when we can make a screw cap of our plastic soda bottles talk. This is one for you, Dave, as our kitchen science guru. He says, you wet them and place them upside down on the opening of a partly filled soda, in other words, fizzy drink bottle. If we don't wet the cap, it doesn't work. If we hold the bottle with 2 hands without squeezing, it talks faster, even after we let go. Why is this? And is this a potential kitchen science segment of the future?
Well, maybe. I guess what's happening here is that you've got a half-filled soda or fizzy drinks bottle, and inside that drink you've got a load of dissolved carbon dioxide, and that will slowly be boiling off. You can see the bubbles coming up all the time, and so it's giving off gas all the time. So the gas is escaping, and it'll be escaping through the little gap around the top. Now, if there's nothing sealing that gap, the air will just escape slowly all the time, so when it's dry it will just escape. But probably if you get some water in there, it will seal it, and the pressure will build up a bit, then it will just pop out a bit, then it will seal, then it will pop, then it will seal, then it will pop, and probably that's what he's hearing.
So much for the singing glass. We wanted to ask you this evening if you know what the first object that was ever made to break the sound barrier. You're speculating like mad on this. Jamie in Bury St Edmunds, well done. You're on very much there with the answer. Fred's in Wyndham. He says the answer's a crossbow bolt. Not quite, Fred. Eros in Wellingborough says the answer's a Bell X-1 aircraft. Not quite. Teresa in Stalham thinks the answer is a bullet. And Joshua in Willingham thinks the first thing to break the sound barrier was the jet engine. Not quite. So what was it? What was the first thing to break the sound barrier that was made by us? If you think you know the answer, or you have a general science question on anything, me, Chris Smith, Kat Arney and Dave Ansell, we're here in the studio. We'll take those questions live on the programme and hopefully get you an answer there and then. The telephone number's 08459 25 2000. Our text number is 07786 20 1960. And you can email us. It's thenakedscientists@yahoo.com.
Anyway, we've had an email in from Gavin Cummings, who was asking us about something we discussed on the show last week, I think, which is about jellyfish, and whether, again, this is coming back to wee, I haven't got an obsession this week, I promise, whether you can wee on a jellyfish sting to make it better. And he says that he lived in Hawaii for many years, and they always carried meat tenderizer, a sort of liquid as a cure for jellyfish stings. And he also said that what they would do if they got a sea urchin sting was definitely wee on that, because there's a theory that the sea urchin spines get stuck in your foot, and if you wee on it, it dissolves the sea urchin spines. Is this true? Is there any science behind it? Well, I've been doing a little research, and I found out that basically nothing really works for these kind of stings. Urine is used as a folk cure all over the place, basically because it's easily accessible. And you can get it on things quite easily. So, for example, from bee stings to jellyfish stings, everyone says that that's the cure. But basically, nothing really works, except possibly hot packs or cold packs or hot baths. There are several ideas as to why people think it works. The placebo effect is obviously very strong. If you're going to do something like wee on your jellyfish sting, you better think it works. And also maybe the fluid going over the sting might help to relieve the pain or wash away any remaining little sting particles that are there. But basically, what you need to do if you get stung, don't wee on it. Try and get yourself to hospital.
Depends how serious it is, though, I suppose, isn't it? Because I got stung by a Portuguese man of war, and it was damn painful, but I didn't take myself to hospital. The worst thing about it wasn't the sting, it was the itchiness that came a week later. So it stung for about a day, the sting totally went away. I came home because I was in the US when it happened. I was here, back in this country, for a week, and then in exactly the same place as I got stung, all up my right forearm, I suddenly noticed it was beginning to itch, and it itched, and I've never had such an excruciating itch. And I think it's a sort of immune allergic reaction almost to what was done to you when you got stung in the first place. And talking about allergies, just to throw forward a little bit, in a couple of weeks' time here on The Naked Scientist, we'll have Professor Karak Sewell on the programme, and he's an expert on allergy. So if you have any questions about the subject of allergies, asthma, hay fever, that kind of thing, then that's the show for you. And if you send me questions up front, we'll make sure that you get them onto the programme. And if you have in the meantime any other questions about anything, our phone number is 08459 25 2000, or of course you can text us on 07786 20 1960. Dave?
In fact, relating to allergies, I've got a question here from Anastasia, age 8, in Doncaster. Hi Chris, I have hay fever and wondered why grass has pollen.
That's because grass needs to reproduce like the rest of us.
Does she mean grass as in cannabis? Or
She's 8 years old, Chris.
Well, what was it? Ali G said, when do you give a kid its first spliff? And John Henry looked absolutely gobsmacked, didn't he? But no, the reason that plants have pollen is because, as Kat says, they need to sexually reproduce. And, in the same way that humans make eggs and sperm, then what you've got in a plant is you've got a stigma on a flower which leads down to the ovary where the plant's equivalent of eggs are, and pollen is like the sperm. And so the pollen, tiny particles that float around in the air, and they're carried there by insects as well. They land on that stigma, and the pollen then grows invasively down into the stigma in a pollen tube, like a little tiny plant within a plant, until it hits the plant's equivalent of an egg, and then it actually fertilises that, and you get in that ovary you get a seed forming, and then the plant spreads that seed to make a new version of itself.
So we have to have pollen to have more lawns, basically, so bad luck there.
It's The Naked Scientists, Chris, Kat and Dave, live with you for about another 30 minutes or so. If you have any science questions for our Naked Scientists science phone-in this evening, 08459 25 2000, or email thenakedscientists@yahoo.com, and send us your text messages, 07786 20 1960. A couple more people have had a go at our what was the first thing we made to break the sound barrier. Joan in Swaffham says a firework. Not quite, Joan. Jeff in Cambridge is on the right lines, as is Helen in Sudbury.
And I think it's Alison here who thinks that it's Martin from Cambridge says it's a bullet or a cannonball. Any of those right?
It's a pretty big cannon, but they're not quite. It makes a big bang. There's a little trick. And I won't give you any more clues quite yet. I'm going to keep you guessing for a little while. Dave, here's a question for you. It's from Miranda by email, and she says, I have a question that my friends have all failed to answer. They even fail to believe it's true until I prove it in front of them. I'd really appreciate it if you could throw some light on my dilemma. Using equal amounts of fruit, squash and water, a drink is always stronger when the squash is poured in before the water, even if you stir either glass. Why is that? I love the show, by the way, Miranda.
I'm not at all sure. Fruit squash, I guess it might be something to do with the way the two are mixing. Was it stronger when he poured the fruit juice in first? Sorry.
Just get it back, Dave, because I'd actually put that on the side. It says, a drink is always stronger when the squash is poured before the water. I don't believe it.
I think it's psychological.
I think it's psychological.
It might be some strange psychological thing with if it's less well mixed, some bits will be very strong, which your mouth will notice, and other bits will just be water, which you'll ignore. So you'll only notice the really strong bits.
I agree. I think it's a mixing phenomenon, because if you normally, I suppose it would also make a difference if you filled it gently with water or put it under a really gushing tap, because you're mixing all the molecules together and dispersing them evenly through the glass. Because at the end of the day, what is flavour? It's molecules that have a taste attached to them, and sugar, which is what the juice has got in it, that spreads out in the water, and it shouldn't actually matter which you put in which order, as long as they spread out completely and dissolve completely, then you should get the same flavour.
You could do an experiment to test that and actually, really well stir them and leave them for a while so they can diffuse around and stir them again.
Be interested to know what the result is.
Yeah, do that at home and find out. Had another answer in on the what's the fastest first thing to break the sound barrier. Paul in Stalham says, was it a lightning strike?
Man-made? Not quite, but that's an excellent opportunity for me to talk and introduce the guy who's going to be on in just a couple of seconds, because we're going to be talking to Mark Skousen, who actually is the how many greats, Dave?
6 is what I've been told.
He's going to be talking about Benjamin Franklin, and the relevance to lightning is that Benjamin Franklin was one of the early electricians. He was an American scientist who did essentially a life-threatening experiment, all in the name of science. And I think that's to be championed but not repeated, which was to fly a kite into a thundercloud and then tap electricity from that thundercloud down the kite string to the ground, where he was able to see it in the form of sparks and collect it into some things called Leyden jars, thus proving that the stuff we could produce on the ground in the form of static electricity must be much the same manifestation as the stuff you see up there in the sky. So we're going to be talking to Mark in just a couple of seconds. If you have any questions for him about Benjamin Franklin, 08459 25 2000, email thenakedscientists@yahoo.com or text 07786 20 1960.
Fancy listening to The Naked Scientists in your bed, on your way to work, or even at work? Why not subscribe to our podcast? For more information, visit nakedscientists.com/podcast.
It's The Naked Scientists, Dr. Chris, Dr. Kat and Dr. Dave, and we're here with you for another 30 minutes this week with our Naked Scientists Science Phone-In. It's a live science phone-in. You just have to call in with any question you want on anything scientific. Anything goes, 08459 25 2000. You can email me, thenakedscientists@yahoo.com, or send us a text message in. The text number's 07786 20 1960. We've heard from someone who called Rob B., Rob's in Brentwood, and he's got the answer right. Well done, Rob. And also Caitlin is in Ipswich, and she's also got the answer to my question, my challenge this evening, which is, what was the first man-made object to break the sound barrier? Now, let me introduce our guest this evening, who's Mark Skousen, who's come over from America. Which bit of America are you from?
New York.
Okay, right there, harsh New Yorker on the top end, east coast of America. Thank you for coming in.
My pleasure.
What's your connection to Benjamin Franklin, and who was he?
Well, I am a direct descendant of Ben Franklin, but Ben Franklin was the first scientific American. He was a great statesman, one of our founding fathers, and a very successful printer. But his greatest love was, without question, science. And he was very much a practical inventor. He wasn't into high theory and academics, but what really worked. And he was an inventor of, I would say 5 or 6 things. I made a list: the Franklin stove, the lightning rod, bifocals, charting of the Gulf Stream, daylight savings, the harmonica, musical instrument. Really quite a remarkable.
How did you come up with that lot? I mean, that's a lifetime's achievement to make one of those things. I'm not sure I know what a Franklin stove is, by the way. Perhaps you better tell me.
Well, it's basically a box inside of a fireplace that allowed the heat to go up and then down and then out. In other words, it stayed longer in the fireplace.
Oh, much more efficient.
Much more efficient.
I could use one of those, because in my dining room we've got this big open fireplace, and you can burn off a bag of coal in the evening. It's just a conduit to the sky for the heat, because the heat just goes straight up the chimney and the room's just shivering in there. So I could do with a Franklin stove.
And it was kind of odd that it wasn't very successful, because it leaked a lot, so smoke went into the area, and it didn't always work that well, but it at least worked in theory.
I mean, I'm staggered by Franklin's achievements in all aspects. Would you class him as a Renaissance man up there with someone like Da Vinci?
Well, there's a book called The 100 Most Influential People in the World, and Franklin is listed there as the most multi-talented genius of all ages. So he's right up there with Da Vinci and others in terms of this broad selection of fame and interests. It's just really remarkable.
And he invented the harmonica, which in my book makes him the coolest man on earth.
Well, yes, because it does require water and so forth. And I should also mention that he would be qualified as one of the first naked scientists, because he had a theory of colds, and he would walk around in the mornings totally naked and have the windows open.
Just to see if he could catch something.
The fresh air and that sort of thing.
He was a man hell-bent on self-destruction, wasn't he? With his lightning experiments and now walking around in the naked.
No question that he He risked his life many times, not only for his country in terms of political, as a statesman, but also as a scientist with the kite experiment. Which
sure.
And he also tried to help people who had problems, physical problems, and he would electrify them. And sometimes he was shocked.
So come on, let's get to the bottom of that. He did what?
Yeah, well, that's right. He on several occasions, a form of shock therapy, which many of scientists at that day believed in.
I mean, also, it says here that he invented bifocal, so he obviously did like helping people. Was he short-sighted himself?
Yes.
Bifocals are for long-sighted people.
No, that's right. Just the opposite. He had a hard time seeing people at a long distance, and also he had a hard time reading as well. I mean, you have to understand that when he invented these, he was over 70 years of age, and he couldn't make out people, especially in France, where he had a hard time with the language. He needed to see what they were saying with their mouth, and he could not. He couldn't really do a very good job.
I have that problem, and I'm normally sighted.
With French?
Yeah, with French, yeah.
Yeah, bifocals are for people who when they get old, their eyes can't focus on things a long way away or close to. They just can't adapt as much. So you have two lenses in them, one a long way away and one close to.
I'm obviously too young to have such a problem.
It's interesting because, as apart from being a scientist, he was very much up there at the front of turning America into something that wasn't part of Britain. Wasn't England anymore. It was going to be its own country. And he took some great risks doing that, didn't he?
Yes, he did. He hazarded his life and fortune, as he often said, and as several other people did who signed the Declaration of Independence in 1776. And he was also a creator of helped to write the Constitution of the United States. So he was a political figure par excellence, a statesman, a scientist. But one of the reasons he hated war, even though he won the war, we won the war against
us baddies.
Country. Yes. He hated war because it took him away from his number one pursuit, which was his avocation as a scientist. And he had many friends who he lost as a result of the war. And so he always said there's no such thing as a good war or a bad peace, and that was one of the reasons he said it. But he also felt that government played a positive role in science. And he was around at the time when Mr. Mesmer, Anton Mesmer, came from Vienna, and he made these. He said you could mesmerize people, and he actually exposed that and wrote an article for the French government to expose that. And he said government has a responsibility to expose fads and junk science in a sense.
That's very encouraging. But one thing that I see here, I don't believe he was truly American, because it says Franklin did not believe in profiting from his inventions. He never tried to make money on them and never tried to patent or trademark his secrets. He felt inventions belonged to the public for their universal enjoyment. Where's America gone wrong since?
Well, I think that's a universal principle. It's we westernize everything. Intellectual rights, patents, trademarks, and so forth is not just an American custom. It's everywhere. But, in the completed autobiography, I think you'll see that he was really a man of wisdom and a very modern person. He would be on the internet today. He would be using cell phones and so forth, while many older people, are afraid of these things, not Franklin.
Now, Mark, just to finish off, you've given me a wonderful selection of stamps. Are these commemorative stamps?
Yes, they are. And I just wanted to point out how the U.S. Post Office couldn't just have one Franklin stamp honoring him. They honor him in 4 different ways: as a statesman, as a printer, as a postmaster, and as a scientist.
And see, he also should have his barber honoured as well, because he's got about 15 different hairstyles in each of these stamps. As Mark Skousen, thank you very much for coming in, and have a great time here in the UK, because you're going to do a bit of a tour with your book, aren't you?
Yes, I am. Thank you.
And we have 2 copies of that book, which is the completed autobiography of Benjamin Franklin, because what Mark has done is actually to finish what Benjamin Franklin started. If you'd like to win one of those 2 copies, or 2 of those 2 copies, all you have to do is give us a call here on The Naked Scientists. 08459 25 2000 is our phone number. Send us a text on 07786 20 1960. Email thenakedscientists@yahoo.com, and we'll see what we can do for you. We've heard from Keith in Brundall, and he's got the answer to my challenge right, as has Brian in Somersham, and Ken in Pakefield, unfortunately, is not on quite the right lines. He said the answer is a hawker hunter. The answer to what? Well, the question is, what is the fastest man-made object? What was the first man-made object, the fastest thing to break the speed of sound in the early days? What was it? Give us a call if you think you know the answer. Dave, here's a quick question for you. Roger's in Wilton on the Naze, and he wants to know what's the highest possible temperature that you can achieve?
There is no highest possible temperature you can achieve, because basically on a really tiny scale, on a microscopic scale, temperature is approximately the amount of energy each atom has, each particle has. Now, you can have the lowest possible temperature because you can have no energy at all, but you can give as much energy as you like to a particle and it will still just keep getting hotter and hotter and hotter.
There's no theoretical maximum.
There's no theoretical maximum at all.
But isn't the energy related to how fast the particles are moving? So is there not a maximum speed that they can reach? There's
a maximum speed that things can reach, the speed of light, but there's no maximum energy they can have, because the speed of light, things have an infinite amount of energy.
So the answer is really infinity.
Infinity, yes.
Infinity temperature, degrees Kelvin.
You get hot enough and eventually the fabric of space begins to melt and then things get very exciting. It's the Naked Scientists, Chris, Dave and Kat, and we're taking your science questions live on the air this evening. In a few seconds we're going to be talking to Catherine, who's in Felixstowe. She wants to know about labyrinthitis. This is when you feel a bit giddy when you've had a cold or a nasty, usually a viral infection up front. We'll talk to her in a second. But first, you can probably remember that in last week's Kitchen Science, Derek was joined by Dr. Ed Turner from Cambridge University and two student helpers who are called Sam and Luke, and they set up some pitfall traps in the Department of Zoology, and they waited to see what kind of insects were going to drop into their traps. Now, today is officially the last day of National Insect Week, which we've been celebrating all of this week, so we're going to go back to the Museum of Zoology and see what they've found. Hi, Derek.
Hello there once again. Welcome to just outside the Museum of Zoology at Cambridge University, and we are here with the results of our pit traps, which Ed Turner from the Museum of Zoology and the Wildlife Trust has set up for us. So Sam and Luke are ready with their results. So why don't we have a look? Ed, would you like to instruct Sam firstly what to do with the cup, which we've just taken out of its position where it was in the garden?
Well, we've got lots of stuff in there, so we need to pour it right on the middle. We've got a white tray here, so we can see easily what the insects are we've got, and right in the middle. So things are already hopping out, actually, as we're doing that.
They are insects, are they, Ed?
Well, they're not really insects. They're like very primitive insects. They've got 6 legs, but they're not actually insects. They're called non-insect hexapods.
Well, hey, OK then. And just tell me a bit about them then. I mean, they look to me like they're maybe 3 or 4 millimetres long. They're crawling around, maybe about as big as ants, but with longer antennae. What else can you say?
Well, if we look at them, we've got some hand lenses here, which you can get from sort of shops quite easily. But they're very velvety, if you have a look at them. I think Sam's just having a look now.
What can you tell us about it, Sam? What can you see with the magnifying glass?
They're quite hairy, and they've got a sort of stripe through the middle where there's a colour change.
OK, then. And also, what are they doing?
Well, they seem to be escaping, and occasionally they'll jump, but they won't go too far.
OK, what's all the jumping about?
Well, actually, that gives you a clue to their name. They're actually called springtails. So what it actually is, they've got a spring at the end of their tail, which is a little structure, looks a bit like an arm, which they can straighten very fast, and it will shoot them into the air. So it's an escape response. And the reason is these things are eaten by nearly everything. So that's why they're a bit nervous, they're a bit twitchy animals, just simply because everything's trying to munch them.
So, Luke, how about you pour one of your cups out there onto one of the white trays that we've got here? OK, there we go. And Luke, where was that one from in the garden?
That was from the lawn.
OK, so that was actually in the grass. OK, then. So what have we got here? What can you see there, Luke?
We've got woodlouse, which is curling up.
OK, yeah, I think I can see. I think I can identify woodlouse as well. Ed, what can you say about that?
Well, it's, again, another interesting response to predation here, so to escape predators or things that are trying to eat it. So what we've got is a pill woodlouse. So its response is to curl up a little bit like an armadillo and protect itself from predators.
OK, so essentially these things think we are predators, do they?
Yeah, no, absolutely. I think they're in fear of their life, but of course they're not going to be harmed today, they're going to be put back afterwards.
OK then, let's have a look at a third cup then. What other one have we got here? Luke, have you got another one there?
Yes, it was in the shade, in the soil.
OK then, so let's pour that out and see what we've got. OK, and what can you see there? Sam?
I think there's a young devil's coach horse. But
OK, and describe that for me.
It's sort of long and black. It's got 6 legs like your average insect, but it's long.
Sounds like we have a real expert here, actually, Ed. What do you say?
Yeah, no, he's absolutely right. It's not a young one. It's a different species. So with insects, the larvae are like a bit like grubs with beetles. So it's a type of beetle, and you're quite right. It's a devil's coach horse. It's a rove beetle, and unlike most beetles, which have got these two big hardened wing cases, if you think of ladybirds, those kind of hardened wing cases. Rove beetles have actually got very tiny wing cases, and the reason is they can then move very easily between the soil or in cracks and crevices and things like that, and often hunt for smaller insects, maybe for these collembolans, actually, these springtails we've already seen.
OK, and one thing that occurred to me as well when Luke poured out this cup that we got from the shady part of the garden was that there were really a lot of insects in there. I mean, is that what we would expect?
Yeah, no, absolutely. I think what we've got here is lots of animals which are living all around the moist ground and in the mud, and so they don't like to dry out too much. This is maybe why we're getting more insects.
OK, right. Well, I think I'm very impressed with the stuff we found here, actually. I'm very delighted as well that it all did turn out fine. So, Sam, what did you think of our harvest of insects here?
I think you definitely got a lot more insects nearer the shade.
Yeah, and I think you guys predicted that, didn't you? I can't take any credit for that, but yes, well done to you. And Luke, what do you think? How do you like the experiment we've done?
Yeah, it was good. We've got lots of insects and different types.
All right, OK, and I think hopefully you at home have heard that it's really very easy to do with a pitfall trap that we've made here. So hopefully you can do it as well and tell us at The Naked Scientists what you find. OK, well, thank you very much to Luke and Sam and to Ed for setting up the experiment. And I hope you have a very fun insect week looking for insects where you are. So we'll be back next week anyway. So until then, it's back to the studio.
Thank you, Derek. And in fact, next week, Derek will be extracting DNA from everyday household items, and one of those things is a kiwi. Not the New Zealand variety. No, we're not extracting DNA from humans now. We're getting it from physical fruits. So if you would like to take part in that, you're going to need some kiwi fruit, some methylated spirits, and a fridge to help you, and some hot water and washing up liquid and a bit of salt. You've done that, haven't you, Dave?
A few times, yeah.
I've done it as well.
We'll be having a go at that. Right, let's have a quick chat to Catherine, who is in Felixstowe. Hello, Catherine.
Hello.
Good evening. Welcome to The Naked Scientist. You want to talk about labyrinthitis?
Yes, please.
Fire away.
In February, I just had this giddiness come on and room spinning. Anyway, I went into hospital, took all different tests, and they took a brain scan, and about 2 weeks later I came home, and the same thing happened again, only it was worse. And then about 4 days ago, I had it again, and I just wondered, why I have it. Is there a cure for it? I mean, what brings it on?
Well, if it is genuinely what they call labyrinthitis, what they're referring to is not something which is part of a Greek bit of mythology. The labyrinths are part of your inner ear, and there's fluid-filled cavities in the ear, and they don't just power your hearing, they power your balance organs as well. So when you move your head, the fluid moves a little bit, and it moves some hairs inside that system, and the hairs are connected to nerves, and those nerves signal to the brain which direction your body's moving in, and then the brain tells the eyes how to compensate and how your muscles should move to compensate for you moving so that you retain your balance. Now, occasionally things can cause that system to go awry. There are a whole host of different reasons why it might go awry and get upset, but a common cause is the common cold or a viral infection, and it can cause quite long-term changes to that part of the ear, and it can cause you to feel a bit giddy and woozy for quite some time, but it does go away eventually if it genuinely is labyrinthitis.
Excuse me, is there a cure for it?
Well, time is the best healer, and actually there's no way of saying we can go in there and fix this, because we know the immune system deals with the virus. If there has been a little bit of upset to that area, it does get better within time, but you just have to give it time. There's no magic answer, I'm afraid.
Really?
Do you want a quick go at the quiz?
I even wake up. I woke up the other morning with it at 5 o'clock in the morning.
I know, it can be it can be annoying, but unfortunately there's no quick fix. But I tell you, I can brighten your evening with a quick go at the quiz.
Okay, what is it then?
Scientists have invented a computer that's the size of a piece of DNA. Do you think that's science fact or science fiction?
I think it's science fact.
Yep, you're absolutely right. Some researchers in Israel have made the world's smallest biological computer powered by DNA. It uses breaking and reforming bonds in the DNA double helix to release energy. And if you have a spoonful of this stuff, it's 15,000 trillion DNA computers.
That's a lot of computers. The Himalayas are at least 500 million years old. Do you think that's science fact or science fiction, Catherine?
Say that again, sorry.
The Himalayas are 500 million years old. Science fact or science fiction?
I think science fact.
I'm afraid not. Part of the reason why they're so high is they're very young in mountain terms. They're only 50 million years old.
Oh, dear.
But 1 out of 2, Catherine, not bad. You're in the lead so far because you're the only person to have done it yet.
Okay.
Take care.
Thank you.
The Naked Scientists, Chris, Kat and Dave, and we're taking your science questions. Anything goes. 08459 25 2000. Email thenakedscientists@yahoo.com or text us on 07786 20 1960. So if you have any question left, then we have a few minutes left of the programme to squeeze them all in. 08459 25 2000. And there is, of course, my challenge for this evening, which was to ask you, what do you think is the first man-made object to have broken the sound barrier? Vic in Chelmsford thinks the answer is the bluebird. Joshua in Willingham has called again. He gets 10 out of 10 for persistence. He now thinks it's the X86 Sabre. I'm not sure what that is. And Dolly on the A14 thinks it's a Spitfire. Not right. What do you think the answer is? 08459 25 2000.
Laying the facts bare, The Naked Scientists.
You're listening to The Naked Scientists. We're answering all your questions. Get calling in. We've got less than 10 minutes left. 08459 25 2000. Had some emails in from Andy in Dover in America. Not Dover, down in the South Coast. He says, The Naked Scientist is the best podcast on the internet. It's all great. The guests are great. The questions are great. The only improvement I can suggest is to get Dr. Cat in the studio more.
Oh, you blatantly wrote that yourself.
And it's not from my mum either.
Oh, yeah, right.
I promise. And we've also got an email here from Richard, who's in Colorado. And he says he enjoys listening to the Naked Scientists podcast, and he also enjoys our British accents. He's an American living in Australia for a year, and thanks to the podcast, he can now tell the difference between Australian and British accents.
Frederica in Western Coville thinks the answer is the Vulcan for my challenge this evening. Not right, I'm afraid. What's the first man-made object to have broken the sound barrier? We'll give you a copy of the autobiography of Benjamin Franklin if you can get the answer right. Right, let's have a quick chat to Joshua. Hi, Joshua.
Hi.
Welcome to the Naked Scientist. What do you want to talk about?
I wanted to talk about insects. This week we've been doing all about how to capture them, put them in jam jars. What you do is you dig a small hole, you put the jam jar in, and you put a bit of food in, and you leave it for 24 hours. Then you come back, and once you're there again, you then empty it into a tray and put it into some jars and just look at them.
So what food are you using? What do insects like?
Other insects, usually.
Lettuce, carrots, peelings.
You get loads of slugs.
A couple.
You're only going to get vegetarian insects, though, aren't you?
No, you get lots of carnivores because they'll go in there and eat all the other insects. How do you know that what you caught wasn't the hungry insects that had eaten all the other insects that were already in your trap?
That's nature, I'm afraid.
Yeah, it is, isn't it?
Problem with science.
But look, I'm going to give you a prize because you've done a fantastic job doing the experiment, which is what we're trying to encourage you on The Naked Scientist, Joshua. Do you want to have a quick go at the quiz?
Oh, yes, please.
OK, you can see the Great Wall of China from space. Do you think that's fact or fiction?
Fact.
Bad luck. No, actually, mathematically, it's impossible to see it from space. It's a bit of an urban myth.
Not bad. Got another go, right? You've got to get this right to stay in the game. Ready?
Yep.
OK, forest fires travel quickest on flat ground. Do you think that's fact or fiction?
I think that's fact.
I'm afraid not. They actually travel fastest when they're going uphill because heat rises and it drags the flames up the hill.
Yeah.
Oh, bad luck, mate. But look, you had to go. Because you've been so persistent with your solutions to our question, we're going to give you a prize anyway, OK?
Oh, thank you.
Thank you for joining us on The Naked Scientist. Been great having you on the show. All right?
Yep.
Take care. And if you have any questions for us, we've got about 5 minutes left. 08459 25 2000, or you can email me, thenakedscientists@yahoo.com, or send us a text message, which is 07786 20 1960. I've got quite a clever solution which has been sent in from Steve in London to my quiz, which was what's the first man-made thing to break the speed of sound, the sound barrier. Very clever, and I'm going to have to give Steve a bonus prize, I think, Dave, because he's suggesting it's light.
Yeah, I mean, things that we do make light, it does go faster than the speed of sound, I suppose.
Okay.
Well, I think he should have a prize. Are we going to find out what the right answer is?
You will do very, very shortly. But look, let me tell you about this first, because a couple of weeks ago, Peter phoned in and said, how much petrol are we burning off, because it is a World Cup weekend, we can go to this, how much petrol are we burning off with all these flags on our cars? And so we said we haven't got the faintest. So luckily, Kyle Butler, who's over in Canada, in Ontario, was listening to that. He makes a podcast called the Brain Food Podcast, and there's more details on that at brainfoodpodcast.com. He replied to Peter saying he did some calculations and reckoned that we're burning off 2 pence in petrol per tank. Now, it doesn't sound like a lot, especially when English pride is at stake, but what's more important is that that's making Gordon Brown £13,700 in petrol revenues, because there are 10 million of these flags all around the place. But then Paul Boutrachat, who's actually listening to us in Hertfordshire, took issue with the answer that Kyle Butler sent in, and he's left a message on our answer phone, and it sounds like this.
Hi Chris, this is Paul Boutrachat from near Stevenage in Hertfordshire. I'd just like to reiterate the question that came up a few weeks ago on the show about the drag on World Cup flags flying on people's cars. The guy that answered the question, I don't think he took into consideration the full aerodynamic principles involved. He just mentioned the fact that the drag on the flag itself, without mentioning the overall effect of the airflow over the car, which has a detrimental effect on the overall aerodynamics of the car. I would like him to reevaluate the question and come back on that one. Thank you.
Well, thanks, Paul. What I did was to send that to Kyle in Canada, and he has responded, thank you very much, Kyle, with the following.
Paul, just wanted to say thanks for the great question. I'm going to talk about the dirty air you mentioned caused by the flag. Firstly, when a fluid flows over a body, it can either flow in a laminar or a turbulent manner. If you notice, there are equations to find the drag force for both situations. Why is this? It has to do with the generation of the eddies you spoke of at high velocities. You are right, this does get worse the faster the car goes. When we initially calculated the force of drag caused by the flag, we assumed turbulent airflow, so the equations already accounted for the generation of these eddies. Now, will the dirty air coming off the flag interact with the car's dirty air to increase the drag even more? Well, now we're getting into more and more unknowns, Paul. Is the flag on the back window or the front window of the car? How long is the stem? At what angle is the flag placed? All these will have an effect on the drag. I think you would agree that the majority of the drag from the flag will be from its direct surface area and not its dirty air stream. Now, I want to drive a point home here that the initial calculations were meant to only give a ballpark estimate of how much effect we're talking here. Even if this dirty air caused a 100% increase in drag, which it wouldn't, it would still only be 1 more pence. I can't stress enough that unless we perfectly define the conditions, where the flag is, which car it is, what speed it's traveling, what altitude above sea level it is, etc., we are hopeless to get anything but a crude estimate. However, this crude estimate is still useful in giving us a general idea of the overall effects. Thanks again, Paul, for the great question.
Kyle Butler from brainfoodpodcast.com. And thank you, Kyle, for taking a look at Paul's question. And thank you, Paul, for a fantastic question. Right, we have a winner to my whip question. The winner is Caitlin, who's in Ipswich. She got it right. The first man-made object to break the sound barrier was a whip, but we had 14 people who got totally right. Sally was on the A17, got it right in the last couple of minutes. John on the A1 got it right in the last couple of minutes. Gerald's in Dagenham, and he also got it right. And loads of you. So thank you all for taking part, and thanks very much for your input into tonight's edition of The Naked Scientists. Kat.
Just finally, we'll leave you with a nice little thought we have from Lauren, who's in America as well. She says that she listens to our podcast on the New York City subway and finds herself wishing that she had a longer journey. You mad, mad person.
Well, that's it from this week's edition of The Naked Scientist, and thanks very much for joining us. Next week, we'll be looking at the building blocks of life. DNA. We'll be joined by Mark Ross from the Sanger Institute in Cambridge, who'll be taking a look at the X chromosome and diseases linked to it, like haemophilia, for example. And we'll also be joined by Michael Traugott from the University of Cardiff, who uses genetics to find out who's eating who on the forest floor. Thanks very much for listening, and in the meantime, if you have any questions on anything science, then send them to us. Chris@nakedscientist.com. See you next week.
Sorting out the sparks from the quarks. The Naked Scientists. For more information, get online at nakedscientists.com.